Now, the practical session, we have this circuit diagram. We have the ammeter, the capacitive load, and the resistive load. What's the information that is given in the circuit is the current passing through the capacitive load and resistive load is 1 ampere. And the value of the reactance is 60 ohm and 60 ohm for the resistive load. So I have now a current passing through a capacitive load with 1 ampere. The value of capacitive load is 60. By using Ohm's law, we will get 60 volt. Why? Because Ohm's law is equal current multiplied by resistance, or current multiplied by either capacitive load or inductive load. So I will get here 60 volt and here 60 volt. The voltage across the capacitive load is 60 volt and the voltage across the resistive load is 60 volt. Now, how can I figure out the source? Can I add them together? 60 plus 60 equal 120 volt. Is it right? Because we have an angle in the capacitive load here, this calculation will not be valid because I have a phase shift between the current and the voltage in the capacitive load. So what I have to do right now, or what I will deal with, is I will have a 60 volt across the resistor and a 60 volt with an angle either up or down, with an angle across either capacitive or inductive load. Here we have a capacitive load, so we will have a minus 90 degree phase shift between the current and the voltage in the capacitive load. So, as I told you, if you calculated, I multiply R, we will get 60 voltage, and the VC, or the voltage across the capacitive load, will be 60 volt with 90 degree angle. Here 0 degree. So what I will have to do is, this is the voltage across the resistor with 0 phase shift, and this is the voltage across the capacitive, 60 volt with minus 90 degree phase shift. Now, if I want to add them together, I will use Pythagoras law, this one, so will be 60 square plus 60 square, all of them under the root, and we will get 84.8 voltage. This is the supply voltage, 84. Now, how can I draw the vector diagram? If I have VR and VL, the voltage across the resistor have 0 angle, and the voltage across the inductor will have 90 degree angle, and the voltage across the capacitive will have minus 90 angle. This is just in series circuit, only in series circuit. I will start with VR 0, then I will go up because the angle is 90 here for VL. I will start by drawing the VR, then from the end of VR I will start drawing the VL. Then this will be the total, the supply voltage. Now, if I have only voltage across inductor and voltage across capacitive, so now the inductive voltage will be 90 degree and the capacitive voltage will be minus 90 degree. So there is no horizontal line, there is no voltage with angle 0, there is no R, there is no voltage across resistance. So I will not go that way. What I have to do is just start with VL from here to here. Then from the end of the arrow of VL, I will go down as a VC. So I will end up with only this one, which is 10 voltage, because I went up 40 voltage and then I went down 30 voltage. The resultant is 10 voltage up. That means here the circuit will be behaved as VL, because the 30 voltage here of the VL will cancel the 30 voltage of the VC. What I have left from this equation is only 10 volt related to inductive voltage. Now, what if I have all of them, VR, VL, VC? So I will start with VL 50, 40, 90 degree, then VR 50, 0 degree, that's why I will go in a horizontal line, then 30 VC, which is minus 90. So I will start by drawing the arrow, then from the end I will start drawing the second arrow. At the end I will get the circuit. I will have this line with 50 voltage because it's parallel to VR. Then I will have only the remaining, which is 10 volt. Now I can calculate Vs. So 50, 10, and this is the hypotenuse, Vs supply voltage. Thank you so much.